an acceptable method of supply power to a 500,000 BTU forced air gas furnace. So again, this is wiring. Six, 808. So we are in installation of electrical equipment. This is heating equipment rated at more than 117 kilowatts. And we are at 500,000 BTU. So I've got to figure out how many kilowatts that is. So 500,000 divided by 3415. So 146 kilowatts. So, and this is heating equipment rated at more than 117. So this was the rule that's going to go in that we want to use. And it'll be all electrical equipment for heating unit, associated equipment with it, other purposes. So supply the furnace, supply the furnace, supply the furnace, a separate circuit used for the furnace only. Oops, jumped it a little hard. Number 11. When working on a scaffold, what is the correct placement of the guardrail system? Knee, hip, and toe. The following is stamped on the body of a fuse. What does the 200 amp stand for? So it's HRC MISC 200 amp. And what is that? It is amps of continuous current. A 6-story apartment building has a total of 40 units. What percentage of the calculated load for unit 16 is required to be used when calculating the incoming service size? So where am I going to get that? It's going to be section 8. Okay, 8202. Apartment or similar buildings, because this is section 8, which is circuit loading and demand factors. Calculated load of the service or feeder from a main service supplying dwelling units shall be greater of item A or B. The basic load of 3,500 watts for the first 4,500 square feet, 1,500 watts. So we want to do not that one. We're looking for the calculated load of the consumer service. So it's saying the 6-story apartment building has 40 units. What percentage of the calculated load for the 16th unit is required? So right here. So I'm going to go 100% of the unit having the heaviest load, 65% of the next two, 40 of the next two, 25 of the next 15. So that's, so we're gonna, number 16 is gonna fall within that range right there, because we've already done 1, 2, 3, 4, 5, and this will do 6 through 20. And we're looking for unit 16. So that falls right there. It's 25%. Well, it's 25%. Number 14, an actuator is set to open a set of contacts 5 milliamps at 20 psi and close them at 20 milliamps at 100 psi. However, it does not work properly when it reaches 5 milliamps, even if the pressure is turned up. What is the problem? So it just tells us that it's not working properly when it reaches, when it's at its low signal. So the actuator is going to have a damaged diaphragm. So that's at the lowest pressure. So that's why. 15. I did 14. Yeah. 15. What is the purpose of flammable fluid seals in a class 1 hazardous location? So I'm going to go to section 18. Seals. So 18 is hazardous locations, right? So process seal or electrical equipment that incorporates such a seal shall be constructed, et cetera, constructed or installed to prevent migration of flammable fluids through wiring of fiber optic systems and used at pressures lower than the marked maximum working pressure. So my answer is to prevent migration of flammable fluids. Number 16, an outdoor 27.6 kV station ground electrode is to consist of which of the following? So here, I'm going to go to section 36. So high voltage installations. And I'm looking for station ground electrode. Every outdoor station shall be grounded by means of a station ground electrode that shall meet the requirements of this Rule 36304 and shall consist of a minimum of 4 driven ground rods spaced at least a rod length apart where practicable and located adjacent to the equipment to be grounded, to have ground rods interconnected by the ground grid conductors of not less than 2 watt, bare copper, buried to a maximum depth of 600 millimeters and a minimum depth of 150 millimeters. So an outdoor station ground electrode is to consist of 4 driven ground rods, connected using a minimum 2 watt copper conductor. Number 17. Where do you find the maximum amount of area that a smoke detector covers? It's in the manufacturer's instructions. Check the manual. 18. What is used to trip an instantaneous circuit breaker and on the occurrence of fault in the circuit that it is protecting? It's magnetic relays or releases. (19) A prox is being used to detect foreign objects coming within 75 millimeters of a drive belt. The prox switch is indicating when a foreign object comes within 73 millimeters of a drive belt. What is the problem? It's not grounded, it's too far away, it's too close, or it's shorted. Well, it's just too close. Number 20. What's the minimum size of conductor that could be drawn into a surface raceway for a fire alarm system? This one I'm gonna go 12 16 2. Surface raceways. And it has information. So we're going, what's the minimum size conductor that can be drawn in a surface raceway for a fire alarm system? Conductors, anything here? Nothing obvious. And the other one is going to be a fire alarm system. So we're going to go 32-100. So 32 being fire alarm, smoke detectors, etc., etc. And then 32-100 is the insulated conductors and cables, except as in provided capacity adequate to carry the current. Optical fiber shall be permitted to use data communication links. Stranded insulated conductors are not more than 7 strands. Here we go. Conductors shall have an insulation rating not less than 300 volts and shall not be smaller. And number 16 for individual insulated conductors pulled into raceways. 19 for individual insulated gauge for integral assembly of 2 or more insulated conductors. 22 gauge for integral assembly of 4 or more insulated conductors. And our question was, what's the minimum size of conductor that can be drawn into a raceway? Minimum size that's pulled into, so it'll be 16. Oh, 16. Number 21. What's the minimum size of copper grounding conductor for 150 kVA, dry type, 600 volt, 3-phase primary, 120 208 volt, 3-phase 4-wire secondary transformer? So I want the size of the grounding conductor. So I'm going to go to section 10. So we are in section 10, grounding and bonding. Grounding conductor size, except as permitted by subrule 2, the grounding conductor shall be size not smaller than number 6 if copper, or number 4 if aluminum. Grounding conductor shall be permitted to be size smaller than prescribed in subrule 1, provided it is not smaller than the current carrying conductors of the system being grounded. I'm going to go number 6. Which of the following starter types are not reduced voltage starters? Number 23. Yeah, sorry, I don't always look back at the public chat, my bad. So yeah, right here, when it says, what's the minimum, up here, sorry, surfaceway, drawn into a surface raceway, that term drawn in means pulled, yes. They're going to try to put questions in that are just stupidly tricky, and they're using language to mess you up. So just be aware that they're going to try to find different ways of asking a question. Like we already did one question where the question asked the permissible amount, but the rule was a negation. It was a restriction. So you had to infer from the rule being a restriction to develop the answer for a permissive. So you're going to get tricky questions like that. Just be careful as you're reading the questions, okay? I got 22 done. Here's 23. 240 volt single phase 60 hertz motor has a lagging power factor of 80% when drawing 23 amps from the line. Ignoring the efficiency of the motor, what size of capacitor will be needed to correct the power factor to unity? So here, I'm going to have to, so I need I need to be able to figure out what size of a capacitor. So I need to get the kilowatts for the motor. So I'm going to go 23 amps times 240 volts. So I've got 5,520 kilowatts. The kilowatts, so it's we're running at 80% efficiency. So I'm going to multiply that. So that's, so I've got 4416 at the power factor or efficiency. To get the size of my capacitor, I'm going to take the square root of the difference of the ideal and the motor amount. So I'm going to make this a negative. I'm going to add 5520, and I'm going to take the square root So I'm going to get 33.2. And they're looking at, so they're looking for kVAR. So like decimal over 1. So it's 3.3. Number 24. What characteristics will a shunt field winding have in a DC motor? High resistance, many turns. Question 25. In an area containing class 2B gases, what is the minimum number of straight threads that must be fully engaged in a rigid metal conduit threaded joint in zone 2? Oh boy. So where am I going to find this? Is class 2B gases. So I'm going to go 18, 1, 5, 2. So hazardous locations. I'm looking for a zone 2 in a hazardous location. So 18 is my hazardous locations. Here's my 18150 is installations in zone 2 locations. And wiring methods in zone 2. Threaded joints that are required to be explosion proof shall be permitted to be either tapered or straight and shall comply with the following. Tapered threads shall have at least 4.5 fully engaged threads, and running threads shall not be used. Metric straight threads shall have a tolerance class of whatever. So in an airly engaged in a rigid metal conduit in zone 2, again, you have to take the best answer. And here it says at least 4.5 fully engaged threads. So I'm going to have to take 5. Question 26. What type of control device does a portable, cord-connected, 2500 watt, 240 volt electric heater require? So I'm going to go so we're in protection and control. It's asking what type of control device does this require? So that's why I've gone to protection and control. So protection and control of miscellaneous apparatus. Additional control devices not necessary. Portable appliances need not be equipped with additional control devices where the appliances are rated at not more than 1500 watts. Provided with cord connectors, attachment plugs, or other means by which they can be disconnected readily from circuits. So what type of control device does this require? A cord attachment plug, a branch circuit breaker in the panel, no disconnection switch is required, and the heater must have a switch. So we're at 2500 watts. Portable need not be equipped where the appliances are rated at not more than 1500. Well, we're more than 1500. Provided with cord connectors, attachment plugs, or other means by which they can be disconnected readily from the circuit. So cord and attachment plug. Cord connectors, attachment plugs. So I'm going to go with provided with or other means by which they can be disconnected readily. So I'm going to go with a switch at it for 2500. Number 27. What is the reason for the installation of a filter in a rectifying system? So it's to smooth out the pulsating voltage. 28. What minimum distance must be maintained between class 2 conductors and any 24 volt class 1 control conductor? I'm going to go section 28. Oh, my bad. I'm answering question 28. Dum. I'm going to section 16. So what class 1 and class 2 circuits is section 16 right here. So the minimum distance maintained between class 2 and class 1. So class 2 conductor and a class 1 control conductor. That's why I'm into section 16. And the separation of class 2 circuits from other circuits. Insulation conductors and cables of class 2 shall be separated by at least 50 millimeters from insulated conductors of electric lighting, power, or class 1 circuits operating at 300 volts or less. So that's 50 millimeters. So 50 millimeters. Number 29. What's the minimum size of RW90 conductors that can be installed in a run of rigid PVC or a 50 horsepower, 600 volt, 3-phase refrigeration compressor? Again, this one's a calculation. So I have to rule 4-006 tells me I have to use 60 degree because I've got no termination temperature given. And then I'm going to go with, so we'll go through this one here. So 4-006. That's 406. We have temperature limitations. For the purpose of subrule 1, except as provided by the rules of the code, where the maximum conductor termination temperature for equipment is not marked, the maximum conductor termination temperature shall be considered to be 60 C for equipment. So you're going to get questions without temperature terminations. So just try to remember that you're going to be using the 60 degrees C column if it's rated at not more than 100 amps and marked for use with number 1 gauge or smaller, or 75 degrees C for circuits rated at more than 100 amps. So if you can try to remember that from Rule 4-006, it'll help with quite multiple questions that will be requiring some calculations. So back to my question, I'm looking for a conductor size. So, and it's a refrigeration compressor. So I'm going to go to section 28. So section 28 is motors and generators, and we're into the refrigerant motor compressors and conductor ampacity. So the allowable ampacity of insulated conductors of a branch circuit supplying motor compressor or equipment consisting of one or more motor compressors shall be based on the marked rated load current of the motor compressor and shall comply with general requirements. Okay. I've got, I need to know my FLA for a 50 horse, 600 volt. I know it's going to be nominally around 50 amps, right? But I can go to table 44 to get that. So I have 50 horsepower, 600 volt, 50 horsepower, 600. So it's 52 amps. That's my FLA. And then I'm going to go back to the rule from dash 706. There. Sorry, full load rating, horsepower rated equipment used for that. Full load rating is not marked. Equivalent full load rating shall be determined from tables 44 and 45. So I've got to go to table 44. Oh, we did that one already. We got 52 amps. So then we have to multiply our 52 by 125%. So we're at 65 amps. And then I'm going to go to table 2. Table 2, allowable ampacities at 60. We're going to go down the 60 degree column. And I've got to look for 65 amps. So I've got to go to number 4. So number 4. Question 30. Line voltage switch is to be installed in an elevator equipment room. What type of enclosure would the switch have to be installed in? So I'm going to go to section 2. So general rules, 400 is enclosures. For the purposes of this code, certain designations will be recognized for the intended use as specified in table 65 and as follows. Type 1 for use indoors in ordinary locations. And I am in an elevator equipment room. That's indoors. That's an ordinary location, probably type 1. For use indoors with enclosure may be subject to drops. No. Of liquid. No. 3R for outdoors. 4 for may get direct streams of water. No. 5 for indoors where atmosphere may contain dust. General purpose enclosures. Other enclosure types tabulated in table 65 shall be permitted. So to be on the safe side, I'm going to check table 65. Enclosure type. Okay, so it's not much more information here. So I'm going to go back to 2-400. And it is a type 1. So line voltage switch to installed in elevator room. What type of enclosure? Type 1. A voltmeter would show what reading across 2 terminals of an energized 3-pole circuit breaker installed in 125 amp 120 208 3-phase 4-wire panel. Being it phase to what wiring method is acceptable for the supply to receptacles under a raised computer room floor? And that's section 12. So we're in wiring methods, and 020 is wiring under raised floors for data processing and similar systems. So what wiring method is acceptable under a raised computer room floor? That's the rule. Covering flexible. Receptacles, we're doing receptacles. Connect data processing. Branch, here we are. Branch circuit conductors installed under raised floors to supply receptacles and junction boxes shall be installed in rigid conduit, electrical metallic tubing, flexible metal conduit, armored cable, or metal sheath cable, including mineral insulated cable other than the lightweight type. And again, we're going to take the best answer. So we can eliminate these three. So that's just going to leave the Tech 90 cable. When we're installing a current transformer, not a voltage, but a current transformer, we're going to be installing a meter. Question 34. A 20 horsepower, three-phase, 480 volt squirrel cage pump motor is protected by a circuit breaker and connected by using STW cable. What's the minimum size cable required? So I've got, I'm going to go to table 44 to get my FLA. So I'm looking at a 20 horse, 480 volt. 20 horse, 480, so 27 amps. And my FLA is 27 amps. So I've got to do my FLA times 125%. So I'm going 27 times 1.25. So now what's the minimum size of cable required? So I'm going to go table. Here's cable, table 12. And I'm looking for STW. There's STW right here. And I'm looking for 33.75 amps. So I got to go up to 35. So I'm going to say on number 8. Minimum size cable is a number 8. Question 35. what's the impedance of the circuit if the total resistance is 500 ohms and the total capacitive reactance is 400 ohms? So XC is capacitive reactance, XL would be inductive reactance, and then R is just the regular resistance. So what's the impedance of a circuit? If the total impedance is 500 ohms and the total, so I want to know what's my total. So my total is going to be the square root of the sum of the squares. So I've got to go uh, 500 squared plus 400 squared equals, that's 4,100, and I need to take the square root of that. So it's 640. So of these, there's my answer, 640. Okay. Question 36. Conductive optical fiber cables can be installed in the same raceway with what other types of conductors? So I'm going to go 56. 2. So section 56 is optical fiber cables. Okay. And my question, conductive optical fiber cables can be installed, and that's why we went to section 56. Conductive optical fiber cables shall be permitted to occupy the same raceway with any of the following systems: Class 2 circuits, communication circuits, and community antenna distribution. So we can't take Class 1. We could take Class 2. High voltage, no. Low voltage, no. So it's got to be Class 2. I'm going to take a quick 5-minute break. So I will be back at 1:16. Okay. I'll be right back then. C of Q. So a late 80s code book. So there's been a lot of changes, a lot of additions. But you can still count on, out of 100 questions, you're gonna count on, 10 or 15 calculations, and at least one, or like I would say probably four or five of those calculations are gonna just try to kill your time. So like as you are approaching the questions, just be aware that they will try to trick you up with time wasters. They will also go and give you a couple of questions that will send you to a code rule, and the code rule will send you to an appendix, and the appendix may send you to oh, pardon me, to pardon me, it'll send you to a table that'll send you back to a different rule. And why do they do that? Because they can. They're just trying to make you run around the code book and waste a bit of time, make it a little bit harder for you to get a good mark. So go in with a plan, be ready for the unexpected, but there's really not much unexpected with the CFQ. They're going to be work-related questions. There'll be a few safety questions. There will be practical questions, a whole lot of code questions. And in fact, for some of the code questions, you probably are going to be able to just pick the answer without even having to reference the code rule dependent on the type of work that you've done, and maybe a question that you may have come across in your work experience already. So, okay, so we're going to carry on. Finished up 36. On to 37. So what are the requirements for grounding high voltage substation fence? So that's going to be section 36. 312. So section 36 is high voltage installations. I'm looking for grounding a high voltage substation fence. So I'm in 36 and I've scanned through, and here we are, grounding a 6312. What are the requirements for grounding? Only fence posts required, no special grounding to be connected to ground electrode at spacing not exceeding 12 meters. Only the top rails are required to be grounded. Just from that, I'm gonna guess without even looking at the rule that it would be C, without even looking at the rule. And here the fence shall be located at least 1 meter inside the perimeter. Station ground electrode shall be connected to the fence by a tap conductor at each end post, corner post, and gate post, and at intermediate posts at intervals not exceeding 12 meters by a conductor of not less than 2 watt. The tap conductor on each hinge coat post shall be clamped, bonded, 2 watt. Tap conductor shall be connected to the fence post bottom tension wire, fence fabric. So it's got to be connected all over the damn place. So only fence posts? No. No special grounding? No. Only top rails? No. Connected to the ground electrode at a spacing not to exceed 12 meters. So it was C. $38. Okay. A communication jack may not be installed in what location? This used to be pretty important because people wanted to have phone jacks in their bathroom, and you weren't allowed to do it. Everyone walks around with a cell phone, so it really doesn't matter. To be clear on that, we can check. So we're in section 60, communication, and it's a communication jack. And communication equipment in bathrooms and areas adjacent to pools shall be permanently fixed to the wall. Okay, so no part can be reached from the bath or the shower. However, it shall be permitted to be activated there. Communication jacks shall not be located in a bathroom right there. Okay. It's kind of like some of the rules are dated because of the way times have changed. People have cut the cord and they're not using their landlines. So these rules are still in place. And we still have to know them. A DC motor obtained its supply from a half-wave rectifier and a solid-state starter. If one diode of the rectifier opens, what would happen? The motor would stop. A half-wave rectifier will only have one diode. And if the diode opens, then we don't have a circuit, so the motor would stop. Question 40. Which wiring method is allowed for conductors used to connect a fire pump and a non-combustible building? So this is going to be for a fire pump. So I'm going to go to section 32. And it is in fact 302. So 32 is fire alarm, smoke, etc. fire pumps. 302, we're under fire pumps. Section 300 is fire pumps. 302 is wiring method. So insulated conductors to fire pump shall be installed in metal raceways, totally enclosed, incorporated in the cable having a metal armor sheath. The type selected in accordance with 12102. Rigid non-metallic conduit where embedded in masonry. Installed in electrical non-metallic tubing where it's embedded in masonry. So we are being asked in a non-combustible building. It doesn't say anything about embedding it. So all I've got in here, because it's not saying anything about it being embedded in concrete, so I'm going to go with Tech 90. Where are we at? I'm approaching the halfway question. Question 41. Increasing resistance of the copper windings in the rotor of a wound rotor motor will cause what to happen to the motor's operation? Decreased torque due to the decrease in the inductive reactance, XL being inductive reactance. (42) What is the temperature code marking of equipment in hazardous areas where diethyl ether gas is present? And this one's going to be one of those ones that makes you run around the code book. So I'm going to start with section 18. So section 18 being hazardous locations. So in a hazardous area where we have diethyl ether gas. So equipment with a type of protection permitted in zone 0, zone 1, zone 2 shall be suitable for one of the following. And this is Electrical equipment for use in hazardous locations shall be suitable for the specific explosive atmosphere that will be present. Equipment with the type of protection permitted in uh, um, 2C consisting of that, 2B. Hydrazine diethyl ether as diethyl ethers group numerals. And it also here is sending me to Appendix B. So I have to go to Appendix B. That's tables. Appendix B. 18. Should be noted that battery operated self-generating equipment not included. Temperature and gas. Okay. I'm looking for diethyl ether. Diethyl ether. Auto ignition temperature is 175. Flash point is minus 45. I think that's it there. Maximum surface temperature ratings for equipment in zone 0, 1, and 2. And I was at diethyl ether up here was auto ignition temperature of 175. And make sure I got that right. 2B 175. And then down here, 175, maximum surface temperature. Um, 175 is T3A, temperature code T3A. Because we're at 175, so we can go maximum surface. Temperature code. Maximum surface is, if the maximum surface is 180, that's T3A, and we have 175. So I don't know if it's T3A or T3B. T3A and T3B. maximum surface. So my question is, what's the temperature code marking of the equipment in a hazardous area where that is present? And it has a ignition temperature of 175. So I'm going to go with T3A for 180. T3A. But that's one of those questions that's going to go and eat up some time because we started on a rule that sent us to an appendix that sent us to some tables, and we had to get there over time with that. Sorry to interrupt. My grandson just walked in the room, so I'm just going to take a 2-minute break and get him back to my wife. Sorry about that. When you've got a 18-month-old running around the house, they come into rooms when the doors are closed. So again, question 42 is one of those questions that will send you running around the code book, okay? Again, we started out in section 18. It sent us to appendix B. We had to go down to a table to get the flash or the ignition point of the diethyl ether, and then go to another table to determine the temperature code for the equipment. So you're going to get some of these questions, okay? Number 43. When connecting an aluminum lug to a copper bus bar using a 3/8 bolt, how much tightening torque is recommended? And that's a table. And we're going to go table D7. Recommended tightening torques. Okay, Appendix D, Table D7. So a 3/8 bolt aluminum lug copper bus. Connection type. There's my 3/8. Screws with recessed Allen or square drives. That's the lug. Again, you have to infer what we're looking for. And there is 3/8, tightening torque 42, right here, sorry, 42.4 Newton meters. Number 44. When working on equipment that has more than one power source, what should be locked out? All power sources. In fact, most places that you're going to work at are going to insist on full lockout of all energy sources. So I work in a car plant out in Cambridge, and I have to be able to lock out. If it's routine entry, that's one thing. But if it is a full lockout situation, I have to lock out all energy sources. So that can be all power sources, it could be gravity, it could be compressed air, it could be any type of fluid power, so compressed air or hydraulics. Again, yeah, potential energy, so lifters and the light gravity. You name it. It can be could require that. So when working on equipment that has more than one power source, we're going to lock out all power sources. What's the maximum rating of an overload that's being used to protect the 20 horsepower, 3-phase, 575 volt squirrel cage motor? So I'm going to go, I need to know what my FLA is for a 20 horse 575. So I'm going to go to So 20 horse 575, 20 horse 575 is 22 amps. And now for my overload, maximum rating of the overload, I'm going to go to section 28. 306. And we should know this almost by heart. Overload devices for motor current, because again, section 28 is motors, shall be selected or rated to set trip at not more than 125% of the full current rating, having a marked service factor of 1.15 or greater, or 115% of the full load if it doesn't have a marked service factor. We don't have a marked service factor, so we have to go 1.15, right? So I'm going to go my 22 amps, which was my FLA, and I'm going to multiply it by 1.15. That's 25.3. And so there's my answer. Question 46. What's the minimum size copper conductor that is to be run from a station ground electrode to the metal bases of gang-operated high-voltage switches mounted in a non-metallic structure in a high-voltage substation? So we're going back to section 36. And so high voltage installations, connections to the station ground electrode. So the minimum size copper conductor is to be run from the station ground electrode to the metal bases of high voltage switches mounted in a non-metallic structure. So we are connecting apparatus mounted on a metallic or non-metallic structure, tanks, frames, transformers, generators, circuit breakers, reclosers, instrument transformers, switch gear, and other equipment. High voltage switches. So this looks like it's the right one. So non-metallic switch gear shall be grounded not less than 2-aught copper, 2-aught. Number 47. Select the largest size solid copper conductor that can be fastened under the wire binding terminal of a wiring device. So section 12. Wiring methods. And we are in the general section. And we will scroll down, termination of conductors. Select the largest size of solid copper conductor that can be fastened under the wire binding terminal of a wiring device. Stranded and solid conductors of number 10 gauge and smaller shall be permitted to connected by means of a binding screw terminal or studs and nuts that have upturned lugs or the equivalent. So is number 10. Number 48. How many conductors are required in a crane pendant when the pendant is required to have 6 push buttons? No, 7. We have 6 push buttons. We need a feed or common, whatever you want to call it. $49. What's the minimum size of copper bonding conductor required in flexible metallic conduit with T90 nylon motor copper supply conductors for 30 horse, 600 volt, 3-phase, service factor of 1.1, a synchronous motor generator when the motor generator's overcurrent protection is time delay fuses. And this is going to be a runaround question again. So I'm going to start with 28. So wiring methods, we're in motors and generators, section 28. 104, motor supply conductor insulation, temperature rating, and ampacity. So what's the minimum size copper bonding conductor required in the flexible metal conduit? Supply conductors. Unless orders marked otherwise, insulation 78 standing. Okay. So I forgot. I've got to get, because again, they're not giving you, all of these questions aren't giving you the FLA. So we're going to go back to table 44 to get our FLA. So a 30 horsepower, 600 volt with a service factor of 1.1. So table 44. So 30 horse, 600 volt, 30 horse, 600 volt. I'm missing something here. Ugh. Uh, yeah. T44. Minimum side block. Fuses. So I'm going to go back to 28,104. I'm actually using the 2021 code here. I'm assuming that you folks are going to be writing on the 2021 code. Um, okay. So supply conductors, table 16A. Insulation temperature increase difference between capacity of that. Insulated motors and circuit continuous duty having passing out less than 125% of the FLA. So then I'm going to go to table 44. For 30 horse. It says that's 32. And my minimum ampacities times it by motor rating. This is table 16A. Take that from unit 4. Okay. I'm going to come back on this one. This one's taken too long. So we'll have to remember to come back to number 49. 50. What size of transformer is needed for a load of 45 amps at 480 volts? 2-wire. This one is size transformers needed for 45 amp. E-line, I-line. So it's just a calculation then. I need my voltage times current divided by 1,000 to get the kVA. So I'm going to go 480 times 45 and then divided by 1,000. 21.6 kVA. What size transformer is needed? And again, we're going to take best answer. Okay. '51. If the peak voltage is 169.8 volts, what will the voltmeter read? Divide it by the root of 2. So square root of 2 as the inverse times 169.8 120. Question 52. 60 ohms, 600 ohms, 800 ohms. What's the power output of the 600 ohm resistor? So my current on all of them is going to be 10 amps. So if I want my power for the 600 ohm, then I'm just going to go I squared R. So it's going to be 10 squared times R. And they're asking for the 600 ohm. So 60,000. 53. 3/3 R90 conductors are drawn into a run of EMT. What's the minimum size that would be permitted? This is wiring. I'm going 12. We're in wiring methods. So 3/0 R90 into EMT. What size EMT do I need? Conduit tubing shall be sufficient size to permit the conductors to be drawn in without damage. The number of insulated conductors. Iron one conduit tubing shall be such the insulated conductors or cables and their covering shall not result in fill greater than specified in Table 8. Usable cross section from Tables 9 and notwithstanding interior cross section of raceway shall be permitted to be derived from their measured internal dimensions. Diameters cross sectional areas of insulated single conductors cables shall be indicated in Table 6. Okay, so I need the cross section of 3/0. So I'm going to go to Table 6A. And there's 3 of them. So I've got 511.92 square millimeters. Okay. Okay. And now how much can I fill that EMT? I'm going to go back to 12. So I gotta remember 511.92. And then I'm going to go maximum number of insulated conductors will not result in greater than that field specified in Table 8. I'll have to go to Table 8. Table 8, maximum allowable percent conduit fill. Number of insulated conductors or multi-conductors, I got 3. Insulated conductors are multi-conductors, not lead sheath. So I can go 40%. And then I want it to go to table 9G. So I'm looking for 511 internal diameter. Here's electrical metallic tubing, EMT, and I've got to get 511 square millimeters for my conductors. So there it is, there's the 40%. So that means that I can use a 41 nominal trade size. And that's it there. 54. It's the smallest size box that can accommodate 14.3 AC cables when there are 5 wire connectors used in making the joints. And again, with this one, we're using box fill. So 12-30-34. Maximum number of insulated conductors in a box. Box is sufficient sized. And then so those are the rules. And we have to go to table. So I've got 4 14.3s. So I've got 12 conductors. And I've got 5 barrettes, so that's another 2 conductors. So I've got 14 conductors. So I'm going to go to table 23. So I've got 14 conductors, and it's number 14 gauge. It's 14. So I can go with a 4 and 2 1/8 octagon, or a 4 and 1.5 square. Or again, the best answer is 4 and 2/8, 2 1/8 octagon. Number 55. What's the maximum rating of the overload devices that can be used to synchronous motor generator? service factor of 1.1. And this one is similar to the one that I think that we took a pass on before, 49, 55. I don't want to. So I need my FLA. It's a maximum overload device. So section 28. Rating trip selection of overload devices, where section 28 is motors, generators. So what's my multiplying factor? 125% of the full load if it has a marked service factor of 1.15, 115% of the full load where it does not have a marked service factor or where the marked service factor is less than 1.15. And my service factor is 1.1. So my multiplier is going to be 115%. So I need the FLA for a 40 horse, 600 volt. Table 44. And this is 40 horsepower, 600 volt. 40, 600 is 40, 41. So then I'm going to go 40, so it's going to be 41 times 1.15, 47.5. The maximum rating of the overload devices that can be used to protect. So I went 306, 47. I'm screwing it up because my these numbers are all too small. Motor rating. I'm not accounting for the service factor. I'm going to skip that one. Service factor is screwing me up here. 56. 4 600-volt three-phase squirrel cage motors. Oh, where are we getting synchronous FLA is 35. Back to 55. Where am I screwing up here then? Where are you getting the 35 FLA for the synchronous? Induction. Oh, for Christ's sake, I'm listening to the wrong column. There we go. Okay, so not reading the questions properly, am I? 40 horse, 600 volt. 40 horse, 600 volt, 35. There we go. Thanks. Thanks, Michael. So we're going to go 35 times 1.15, and we're going to get 35 times 1.15. I got 40.25. 40.2. So there we go. When you're looking, read the questions and look at all of the table. Right there, that whole section, there's all the synchronous. Totally gapped that out. Okay, 56. 4 600 volt three-phase squirrel cage motors are connected through a splitter. What's the minimum size of R90 conductor that can be run in a conduit between the fusible disconnecting means feeding the splitter and the splitter if the motors have continuous ratings of 20, 20, 15, and 10. So I'm going to go back to table 44, and my 20 is 22 amps. My 15 is 17 amps. My 10 is 11 amps. So the conductor ampacity is going to be the largest FLA times 1.25 plus all the remaining FLAs. So my largest ampacity is the 22 amps. So I'm going to go 22 amps times 1.25 equals. And then I'm going to go, I've got another 20, 15, and 10. So another 20 is plus 22. 15 is 17. And 10 is 11. I'm at 77.5 amp. Okay, so now I'm going to go table 2. Here's table 2. And I want to know the size of the RW90 running a conduit between the fusible disconnecting means feeding the splitter and the splitter if the motors have these continuous ratings. So no termination I've got no termination temperature termination given. So I'm going to go with the 60C column. And I need, so down the 60, I'm going to go with a number 3. So no termination, so that means I'm going with a number 3. $57. What's the maximum size of non-time delay fuse for a single phase 240 volt 10 horsepower fan motor? So I'll go 28, 200. What's the maximum non-time delay fuse for a single phase 10 horsepower fan motor? Branch circuit overcurrent. I'm on 57. By an overcurrent device. Non-time delay, time delay, instantaneous. Rating of recurrent should be required by not exceed the values given in table 29 using a full rated full load current on the motor except over 15 amps shall be printed. So I want to go to table 29. Rating or setting overcurrent devices for the protection of motor branch circuits. This one is single phase, 240 volt, 10 horsepower. Non-time delay. Use rating. I need my FLA, the single phase. I need to go, I forgot, table 44, or is it 45? Need my FLA. Okay, so 240, 10 horse. 240, 10 horse, 50 amps. I'll go 50. And then I got to go back to table 29. Okay, so single phase, all types, time delay fuses. current. Roll cage. On time delay. My single phase. 29. I got 50. So I got 50 amps. And full load current, single phase, all types, 300%. So I have to do 300% times 50. So we'll times that by 3. So we get 150 amp fuse. There we go. Okay. 223. I'm going to take a quick 5-minute break. And I'll be back at 228. Okay. Carrying on, question 58. Good thing is this keeps a tally of what we've answered. I'll have to try to get back to question 49. Okay. So we are now, we started roughly at 12:10, something like that. So I'd like to be able to get it done in the mandated 4 hours. So what's location is a category 1 location. So I'm going to go and look for two. Locations in which corrosive liquids, vapors, or excessive moistures are likely to be present. So we're looking for the location is one in which moisture in the form of vapor or liquid is present in quantities that are liable to interfere with normal operation of electrical equipment, whether the moisture is caused by condensation, dripping, splashing. Category 2, location in which a corrosive liquid or vapor is likely to be present in quantities that are likely to interfere. My question, what is a category or slaughterhouse? Pulp mill, tannery, or brewery? So any of these have moisture in the form of vapor or liquid present. Pulp mill, maybe. Tannery, maybe, yeah. And that might be liable to interfere with normal operation of electrical equipment, whether moisture is caused by condensation, dripping, splashing, and otherwise. Clear on this yet? So, and it does say Appendix B. So I'm going to go to so here I'm in Appendix B. Examples of some but not all occupancies of Category 1 and 2 locations may be encountered in the list of Table B22.1. Category 1 and Category 2. So abattoir is a Category 2. Pulp mill, that's also a Category 2. Tannery is also Category 2. Brewery, that's Category 1. Which location is Category 1? Brewery. Again, that one's a bit of a time waster. Question 59. What's the minimum size of copper grounding conductor for high voltage lighting arrestor in a high voltage substation? So high voltage again. So we're going to section 36 and lightning arrestor. High voltage connections to the station ground electrode. All metal items form a part of this. All these metal structures, apparatus, lightning arresters. The lightning arrestor shall be connected to the station ground electrode by a conductor of not less than 2 watt. What's the minimum size copper grounding for high voltage lightning arrestor? 2 watt. Question 60. What does the term cardiac contact mean when describing the function of a patient care area? So cardiac contact. Where's the definitions? Let's go definitions. Not in there. Nope. Okay. Then how about 24? Is patient care areas. Oh, okay. So it's in the definitions or the terminology for the section, not in the for the whole code book. I was looking. I was looking for it in the definitions for the whole book. So cardiac contact, intentional contact directly to the heart by means of an invasive procedure. Intentional contact directly to the heart by means of an invasive procedure. B60 horsepower, 600 volt, three-phase squirrel cage are connected to a splitter. What's the minimum size of our 90 conductor? When run an EMT between fusible disconnecting, temperature reading of 75 C in the splitter. So my termination this time has a temperature given. So 60 horsepower, three-phase squirrel cage. So we'll go table 44. So 60 horse, 600 volt, 60 horse, 600 volt, 62 amps. And there's three of them. So what's my conductor between the fusible disconnecting means and the splitter? So I've got to take, they're all the same. They're all 62, right? They're all 62. So I've got to multiply the first one by 1.25 and then add the other ones straight up. So I got 201.5 amps. And then I'm going to go to table 2. So this time, my termination temperature is given 75 C. I'm going to use a 75 degree column. I'm looking for 201. And when you know it, I just went over 200. So I'm going to go 4-aught. I'm going to go up to 4-aught here. I'm going to go 4-aught. Number 62, 4 to 20 milliamp transmitters converting 50,000 to 1 million ohms is converted to measure 50,000 to 1 million ohms. What would the voltage measurement be if the transmitter was putting out a signal of 11.2 milliamps? So I'm just going to go and I need to get my ratio for 4 to 20 and my signal span and my variable span, right? So I'm going to get 1 million minus my lower variable, 50,000. Oops. Backspace. That's 950. My signal span is 20 minus 4, so that's 16. So I'm going to divide this by my, okay. So now I've got this ratio and I've got 11.2 milliamps. I'm going to multiply 11.2 milliamps times that minus my offset. My offset is 4 to 20, so I have to subtract the 4. So I'm going to go, I'm going to put that into memory. And I'm going to go my 11.2 minus my 4, which is 7.2, and I'm going to multiply what I had in memory. So I get 427,500. So what voltage measurement would be if the transmitter was putting out a, I think they're just a typo, they fat fingered it. But anyways, we're looking for our process variable. So if our signal variable is 11.2, what's a million? And our signal varies from 4 to 20. So they just want to know what's our process variable. If our signal is 11.2, it's 427,500. That one right there. Number 63. What's the minimum amount of coverage over a direct burial cable TV system when the cable is to be direct buried in a parkway? So I'm going section 54. And we're looking for direct here underground 54,700. Installed outside and maintain a horizontal separation. Place the minimum depth of 600 millimeters unless rock bottom is encountered, in which case the minimum depth of 450 shall be permitted, except that for service cables under parkways, lawns, the depth shall be permitted to be reduced to 450. So, service 50, minimum B. When using a cylindrical bushing to protect 12.2, running through wood stud, what is the minimum required distance? It must extend beyond both sides of the stud. That's going to be 12. Wiring methods. Non-metallic sheathed cable. NMD90. Protection of cable. Cylindrical bushing size from a hole through the member extending a minimum of 13 millimeters beyond both sides. Cylindrical bushing, both sides, 13 millimeters. Question 65. What's a minimum working space that must be left around electrical equipment that has exposed live parts when the operating voltage of the equipment is 9 kV? Oh, pardon me. Working space around electrical equipment. We're under the general, section 2. Working space, minimum working space 1 meter. Working space shall not be but we're looking at voltage. That's a lot higher. Okay, working space with secure footing, not less than that specified tanks provided. Electrical equipment. And this is electrical equipment. But having exposed live parts. Oh, it has exposed live parts. So it looks like I have to go to table 56 here. Minimum working space around electrical equipment having exposed live parts, nominal voltage to ground, 9,000. Right here, 2,501 to 9,000, 1.5. 1.5. What's the maximum output rating of a class 1 control circuit restricted to? Class 1 and 2 circuits. The maximum output rating of class 1 is restricted to limitations. Class 1 extra low voltage power shall be supplied with a source rated output not more than 30 and 100 volt amps. Class 1 remote signal shall be supplied by a source not exceeding 600 volts. 600 volts. Question 67. Motor is controlled by a frequency drive. The operator is trying to run the process with the motor operating at low speed. If the motor buzzes but does not turn, what is the probable cause? Probably the frequency's just been set too low. Rapid start fluorescent ballasts sometimes fail to energize. When the circuit is energized, the ground limits to the current. Luminaire is not grounded. The circuit. So that's luminaire is not grounded. You guys don't have to worry about that too much unless you're replacing all the fluorescents with LEDs. 69. A PLC-driven assembly line is developed and error during a process. Broken limit switch has been replaced, but the error persists. What drawings should be consulted next to further troubleshoot? I'd be looking at the logic. Question 70. If a watt-hour meter is hooked up backwards to line and load conductors, what would be observed? Negative. That's like your meter on your house if you flipped it around upside down. A line voltage switch to be installed in an elevator equipment room. What type of enclosure would the switch have to be installed in? A line voltage in an elevator room. (2-000) enclosures 400. Elevator equipment room, what type of enclosure? For use indoors. I would say type 1. There is an Appendix B in Table 65 if we wanted to check that. It looks like it's a type 1. Yeah. I'm saying type 1. 72, a three-phase transformer bank consists of three 37.5 kVA 600-volt single-phase transformers with no marked temperature rating. That's the minimum size of R90, RW90 copper. It can be used to run a flexible conduit to feed the three-phase transformer bank. Okay, so again, I got no temperature rating. Let's see here. So transformer continuous load. Okay, so purpose of overcurrent protection. Overcurrent protection. I'm doing the line side conductor sizes. So not on the single. I'll listen to some of them. So 125%. So I need the total. For my transformer bank. That's a three-phase bank made up of that. So I'm going to go 37.5 times 3. So I'm going to get my primary winding ampacity is going to be my kVA, my three-phase kVA, that times 1,000. And now that's just VAs. And I'm going to divide that by my voltage multiplied by the root of 3. So I'm going to go, oh darn, let's go memory clear. I'm going to go back to my kVA. So hang on. That was 37.5 times 3. And now I've got to multiply by 1,000 to get VA instead of kVA. And I've got to divide that. So I'm going to put that into memory. And my denominator is going to be my voltage times the root of 3. So that's going to be 600 times 1.73. And that's my denominator, so I'm going to make that an inverse. Multiplied by my memory. And gives me 108 amps on the primary side. But conductor side says I have to be 125% of the rated primary current. So I just calculated the primary current at 108. So I got to multiply that by 1.25. So I got 135. And I'm back to table 2. No marked temperature rating. But this is 600 volt, right? Because it's 600 volt. If I go back to rule 4-006, at 600 volt, I go to the 75 degree column, not the 60 degree column. So my 75 degree column, and I'm looking for 135. And again, we're just over the 1, so we're going to the 1-aught. So it's going to be the 1-aught. There. Okay, number 73. On a routine inspection of a termination, the insulation in one of the phases of the conductors was discovered burnt. What's the likely cause of the burnt? Loose connection. It's always a loose connection, isn't it? While working on electrical installation on a construction project, changes are required to be made. How are changes official drawings tracked officially? Weekly job site meetings. When connecting a 100 amp lighting panel to an 800 amp splitter, what is required? Lighting panel, what is required? Conductors, overcurrent protection. Okay. Overcurrent. I'm thinking it's this one. So I think it's overcurrent. Panel board overcurrent protection. Except for panel boards with more than 90% of the overcurrent devices, supplies, feeders, or motors, every panel board shall be protected on the supply side by overcurrent devices having a rating not greater than that of the panel board. So overcurrent protection. What is the maximum distance of 1,000 kc mil copper conductor can be run unsupported in a raceway, run vertically in a shaft? Conductors and hoistways. Supporting of conductors. Run vertically in a shaft. Vertical runs of, what are we running here? RW90. Looks like I have to go to table 21. Supporting insulated conductors in vertical runs of raceways. And this is 1,000 kc mil conductor. Looks like it's 10 meters. Over 750 is 10 meters. I'm going to go with 10. 77. Control circuit is required to carry 8 amps of current at 120 volts. If the control conductors are run in parallel, what's the minimum size? Okay. So conductors in parallel, ungrounded. If they're smaller than 1 knot, shall be permitted in parallel to supply control power. They are contained within 1 cable on capacity sufficient to carry the entire load shared by the parallel such as impact. See Appendix B. So for 8 amps, I'm not sure. I'm going to guess 16. What else have we got here? Where else can we look? Extend. Okay. I'm not sure. I'm not sure of this one. I'm going to go with 16. 78. What's the current carrying capacity of a conductor required to feed a 60 amp fusible switch, the 400 amp splitter, if the switch is located at least 3.5 meters away from the splitter? So I'm looking for so the minimum tap conductor. Okay, so I'm gonna go 14. What's the current carrying capacity of a conductor? 400 if the switch is located at least 3.5 meters away from the splitter. And ground is protected by an overcurrent device at the point where it receives its supply, except that such protection shall be permitted to go for the following cases. Capacity is 1/3 that of the larger conductor from which it is supplied. It's less than 1/3. Okay, it's not more than 7.5. We're not more than 7.5, so we're 3.5. So the minimum size is going to be we're going to get 400 divided by 3. We got that. Noises appearing on a shielded communication cable. What is the problem? Cause. Shielding problems. The shielding should only be connected at one end. Question 80. The transformer can be energized from either direction, as is the case with standby connections involved. How much the overcurrent device for the transformer will be calculated? Interconnection of electrical power production sources. Transformer overcurrent protection. Overcurrent protection for a transformer that is energized from both directions shall be provided in accordance with Section 26 by considering first one side of the transformer, then the other side as the primary. So you have to treat both sides as the primary. Okay. What's the minimum size of T90 nylon that can be installed in a run of EMT that is used to supply a 208 three-phase 25 kVAR dry-type capacitor? So I'm going to do my ampacity. I need to get my ampacity. So I'm going to do my 25 kVAR times 1,000 to get rid of the kilo. And I have to divide by my supply voltage. .73, and that's the denominator, so I'll just invert it and multiply it by that. So that's my current. What's the minimum size conductor? And I have to go to 26 200. Capacitors. Conductor size. Capacity of a capacitor feeder shall be not less than 135% of the rated current of the capacitor. So that's my current, my rated current for the capacitor. So I have to multiply it by 1.35. So there's my ampacity of my conductor. And because I'm at 208, I'm going to go to 4006. So if it's rated at more than 100 amps, it's 75C. But so I've got that. So I got to go to table 2. So I've got 93. So I want number 3 off the 75-degree column. Minimum size to be installed. Oh, because the circuit breaker has a 75-degree termination. So we notice the circuit breaker has a 75-degree termination. So that's why we're looking at the 75-degree column. Another tricky question. Okay, they're going to try to mess with you in different ways. So I'm going back to 75. I got 93. So I'm going to a number 3. Okay, I better pick up the pace here a bit. 82. When grounding a metallic fence fabric on the gate from an outdoor station, how many points of contact are required between the fence fabric and the tap conductor? That's 36, high voltage. Metallic fence enclosures. The tap conductor shall be connected to the fence post, the bottom tension wire, the fence fabric, for which the conductor may be woven in at least 2 places, the top rail and each strand of the barbed wire with connection to the bottom tension wire, fence fabric, barbed wire made with a bolted or equivalent connector. When grounding the fabric, how many points of contact are there? 2. That's right here. Each fence fabric for which the conductor may be woven in at least 2 places. When natural gas is expected in the air periodically in a new installation, what would the electrical equipment in this location be classified as? That's going to be the 1800. Ah, hazardous locations. So this is natural gas in the air periodically. It's periodically. It's not likely under normal. It is not likely to occur normally, but if they do, it will exist for a short time. So it's a zone 2. When terminating aluminum, number 10, how far and in what direction must the aluminum conductor extend around the terminal screw and in what direction? Well, we know it's got to be clockwise. So is it 2/3 or 3/4? I'm saying 3/4. 85. What condition of use is SJOO designed for? I want to go to table 11. So I'm looking for SJOO. SJOO for hard usage. Damp or dry hard usage. So it's damp or dry. It's not hard usage. SJOO. I would say hard usage. I will say outdoor because that's wet. I'm going to say dry. 86. What's the minimum number of leads, including supply for a 2-lamp rapid start fluorescent luminaire ballast? I don't think any of you will remember that. 8. 87. How often must an emergency system be tested? Monthly. Question 88. What's a magnetic instantaneous circuit breaker designed to do in a motor branch circuit? 28 dash. Overcurrent protection. groups, motors, size of fuse holders, instantaneous trip circuit breakers. When used for branch circuit protection, instantaneous circuit breakers shall be rated at not more than 1300 in the full load current and not more than 215 of the locked rotor current. There's 215 of the motor's locked rotor current. No, that one. 89. The switchboard with exposed live parts operates at 2400 volts. If the room has 2 exits, what's the minimum working space? Working space. Looks like we're going to table 56 again. Switchboard exposed to live parts. If the room has 2 exits, what's the working space? So I need to go to table 56. Minimum working around electrical equipment, exposed live parts, square footing. So a lot of this is stuff that doesn't really matter. What we should have just been focusing on, switchboard exposed live parts, 2400 volts. And that will be 1.2 meters. Right in there, the second one. What characteristics will a 2 capacitor motor have? Good running torque and high starting torque. 91. When a supplementary protector is allowed to be used as the only protected device in a branch circuit. Not sure. Protective devices. Supplemental. So application of supplementary protectors, supplementary overcurrent. Appendix B. Supplementary overcurrent protectors is composed. Branch circuits. That's not helping me much. Well, it can't be anything with supplementary can't be right. So in fact, all three of these have supplementary. So that means that I'm going to go with this one because here it says supplementary overcurrent protectors used as components of some appliance equipment are not suitable for protection of branch circuit conductors. So there we go. 92. What's the maximum number of recessed luminaires that can be connected to a 120 volt residential lighting circuit protected by a circuit breaker when the wiring is 14.2? Note the recessed luminaires are built to house only a maximum of 60 watt incandescent. Again, these are kind of out of date. So I'm going to do I got 120 volt and a 15 amp circuit, right? $120 times 15 is 1800 watts. How much is available? Would be 80%, right? So times 0.8, 1440 watts. And then if each one was a 60 watt, 24. So that's it there. 93. What must be done to the metallic box connector used when terminating a non-metallic sheet cable to a non-metallic outlet box? If we're not sure, we're going to go to 12. Outlet boxes. When the metal fittings are used to terminate non-metallic wiring method to non-metallic outlet box, metal fittings shall be bonded to ground. Bond the box connector to ground. That one. 94. What characteristics will a capacitor start motor have? Capacitor start will be low inrush, high starting torque. What type of controlling means is required to upgrade the wiring for a 5 horsepower milling machine in a machine shop? I'm going to say a magnetic motor starter, but motor shall be disconnected. So we need, because this is a milling machine, we don't want a manual switch. We don't want an attachment plug, an isolating switch. We want a magnetic motor starter because we don't want it to just When automatic restarting is liable to create a hazard, the motor control device shall provide low voltage protection. So there we go. '96. The minimum size of the grounding conductor for a 500 kVA dry type 27.6 kV three-phase. So so 96. Minimum size. Grounding conductor. So grounding and bonding. Minimum size 500 kVA, phase 4,160 volt, phase primary, 4-wire secondary, high voltage, grounding, bonding. Material size, ground grid. Grounding conductor. So the transformer neutral on a solidly grounded neutral system shall be connected to the station ground electrode by copper, shall not be less than 2 watt. So 2 watt. Basically that 2 watt keeps coming up again and again and again for all that high voltage bonding and grounding. 97. Which statement is true regarding the installation of a bare element water heater? It may be connected using a supply cord. It does not need a GFCI. It must be located from there. It must be supplied from a grounded system. Two. Trace heaters, heating panels, and ducts and vessels. Bare element water heater. A bare element water heater shall be supplied from a grounded system permanently connected to a branch circuit that supplies no other equipment, protected by a ground fault circuit interrupter of Class A type. It shall not be located within 1.5 meters of the utilization of the heated water. That's not right. It does have to be ground faulted. All of these are wrong. This one is correct. So it can't be supplied by that. it does need to be supplied by ground fault, and it's got to be more than 1.5 meters from the outlet. That's the D. 98. When using an extension ladder to gain access to the roof, what's the minimum distance ladder is to extend above the roof line? 3 feet. The plate electrode is what type of grounding electrode? Artificial, in situ, manufactured, field. It's a manufactured. A single dwelling is supplied with electrical power from the local authority. The owner of the single dwelling wishes to interconnect his solar photovoltaic local supply. What's required to interconnect the two electrical power supply systems? If we're not sure, we're going to go to section 84. Okay, looks like it's an inverter in here. Interconnected electrical power sources shall provide protection from backfeed. Sources shall be equipped with necessary means to establish and maintain synchronous condition unless an alternative procedures followed. Accordance of the supply, electric power production sources shall, upon loss of voltage in one or more phases, be automatically disconnected, not reconnected. An inverter suitable for the interconnection of electrical power production and designed to service a disconnection device shall be permitted to use to meet the requirement of this. So I'm going to say inverter. Okay, we got 15 minutes left, and I missed the question. I missed 49. So, what's the minimum size of copper required in the flexible metal conduit T90, 30 horsepower, 600 volt, 3-phase, service factor of 1.1, synchronous motor generator? So I'm looking for the current. So I'm going to go back to table 44. Okay. And this is 30 horsepower, 600 volt. 30 horsepower, 600 volt, but it's synchronous, so it's 26. So my FLA is 26 amps. Clear that, memory clear, and that is 26. Okay. Well, what's the minimum size copper bonding conductor required? So I'm going to go 28, 100. Wiring methods. Insulated conductors for branch circuits to be 125%. Okay, so I'm going to have to go times 1.25. That's 32 and a half. And 600 volt, so it's going to be 75-degree column. Okay, so the conductor is going to be a number 10. And I'm looking for a bonding conductor. Minimum size of bonding jumpers and bonding conductors. Amperage rating setting or overcurrent device. Blah blah ampacity, largest ungrounded conductor or group of conductors. So we've got the ampacity of oh shoot, 32.5, which was a number 10. And so 32, our ungrounded conductor is 32.5, which is a number 10. So we have to go up to 60 here. So then my minimum size of bonding jumper bonding conductor is a number 10. Oh man. Okay. Let's see how we did. We got 96. So you're asking about question 49. Let's go back into it. 29. Because it's 600 volt. Okay, hang on. What's the minimum size of copper bonding conductor required in the flexible metal conduit or motor when the motor generator's overcurrent protection is time delay fuses? So again, it's giving us a bunch of extra. It's giving us extra information that we have to sift through. Okay. What we need to do is we need to find out what our supply conductors are. So to do that, we got our FLA from table 44. So and I'm not sure what you're referring to here. Table 55. Yeah, so this is asking for the bonding conductor. So going through this once more, I got a number 10 as my conductor size, and then table 16 was 32 amps, so allowable ampacity of the largest ungrounded conductor or group of conductors. So I have to step it up to 60 there. And that means that my minimum size of bonding jumper or bonding conductor is a 10. I'm not sure how to see the ones we didn't get right, because this is a new one again. Maybe it lets me in again. Nope. Okay, hang on. Top left. Yeah, so again, so what you're asking here is ampere of rating or setting of the overcurrent device, or the allowable ampacity of the largest ungrounded conductor. Our question I'll jump back in here. So it's asking the minimum size copper bonding conductor required, and the ampere rating setting of the overcurrent device. Here it's telling me the overcurrent protection is a time delay fuse. It's not giving me the size of it, so I'm not going to try to calculate the time delay fuse. I don't need to. I've got, what I can do is I can get to the size of I can get my table 16 value by either having the ampacity of my conductors or the ampacity of the overcurrent device. So I went with conductors because it's easier. So because I was able to, from my question, I was able to determine what I needed to feed the motors with. So I went 26 times 1.25, 32.5 amps, and then table 2, 75-degree column. And I got a number 10. And then from table 16, it was, sorry, it was a number 10. And so it was 32.5. And then I had to go with a bonding conductor, the bonding conductor of the largest. Yeah. That's where. I'm not sure what you're referring to, 1.25 or 1.75. Okay, this thing is going to time out at 4, so it's going to time out in about 15 seconds. I'm going to set up another virtual for 4:30, so I'll see you then. Or maybe it's not going to time out. It's weird. Now, if it's not going to time out, I'll just leave it running. Why don't you do take a break for half an hour, and we'll reconvene at 4:30. I'll just leave this open as is, and then we can cover anything else that we wanted to cover off. Okay, so I'll meet everybody here at 4:30. Thanks. Read all of the questions and make sure that you're getting the information straight in the question. And when you're looking at the tables, make sure you're interpreting it. They're going to give you wordy questions. So once again, you're going to get some questions that will be asking what is not allowed, and the code will be what is allowed, or vice versa. It may be they're asking what is allowed and the code is telling you what what is not allowed. So you'll have to go and make sure that the tricky language that they're using is, you know, like don't get caught up with it where they would go and have you, you know, like where you might, because they might give you an answer that is incorrect, but if you know, weren't reading the question properly, you might mistakenly put the wrong answer in. There's going to be questions like that where they're purposely trying to trick you up. There will be questions that send you on a bit of a loop. So again, it'll be a code reference that'll take you to an appendix, that'll take you to a table, something like that. Again, and have a strategy for when you're writing your CFQ. Go and answer all the quick and easy ones first, then go back and answer the more difficult ones. The ones, I mean, if you wind up on a calculation one where it just starts going sideways, write down the number, put it aside, and move on. You don't want to go and waste 20 minutes on a single question that counts just as much towards your final mark of the CFQ as a simple true or false or multiple choice, okay? So make sure that you're, get all the ones, get all of the marks that you can get right away, and then go back and get the ones that you, that you're not, like that you may have to do some digging. Also, I was trying to go to the code reference for each one of them, and there were some where there were no code references. It was just off of work experience, so that's easy enough. And there were even some that I probably could have skipped doing the code lookup because I was pretty confident with what the answer was going to be. Again, I'll leave that for you to figure out how far you want to take that. But also, make sure you answer every question. There's no penalty for a wrong other than it's wrong. So even if you're guessing, you know, guess, because maybe you'll be lucky enough to get a couple that are right. Okay. Once you've got your CFQ, like I said, all you folks are going to be unicorns. The marketplace is always looking for licensed tradesmen, tradespeople, and wages have gone up. I'm in the auto industry, and we're at 52, and we'll be within a couple of years, we'll be at 56. So I know that there are other employers that are a little bit above and a little bit below us. So lots of opportunities. It depends on what you want to do. If you like construction, if you like maintenance work, if you like whatever, you know. But know that you made good choices. You made a good choice getting into the field, and you're real close to the end. So don't stress it. Just go out there and knock it out of the park, and you know, you'll be fine. You know, I did my CFQ over 30 years ago, and was lucky enough to do really well on my first go round. Didn't have to do it a second time, but again, it doesn't matter. No one's going to ask you how many times you wrote it, so don't stress it. Just go and prepare. If you are prepared, you will pass. It's as simple as that. It's just a matter of being prepared. You obviously can't take your own code book into the CFQ. You're going to be working with a provided code book. So be familiar with some of the sections that you can get to quickly. It's a shame that you can't use a PDF. It'd be a lot easier. I mean, out on the job site, that's probably what you're going to be using most of the time is just a PDF. But for the CFQ, you're going to do it old school with a great big brick, great big paper brick. So it'll be fine. You're going to do okay. You've gone through a week of prep. You've gone through almost 5 years of prep for it. So don't sweat it, and just know that you're prepared and you're going to do well. And like I said, once you are licensed, you're going to be unicorns. You're going to have headhunters calling you all the time, and you're going to be able to pursue whatever area of the work that you want to do. I mean, for myself, when I was younger, I did mostly commercial and industrial construction and maintenance. And after a couple of years of doing quite a bit of rooftop work, I got tired of it and I wanted to be under a roof instead of on top of a roof. And then all I did was I just looked at where is the best paying jobs for electricians that's under the roof, and it was in the auto industry. And so that's why I went that route, because I am a 309A, but you know, I'm basically done nothing but robotics and PLCs for close to 27 years now. So there's lots to do, lots to learn. I would just go and say, just for this CFQ, be prepared, and you'll be just fine. Again, for any of you who came in a little bit late, under content, you will find CFQ quiz and answers. So there's a couple here that are the questions and answers are available. So that's for number 2 and number 3. And under the assessments, you will find under quizzes, you will find there's 2 and 3. Okay. Sorry, Nathan, what were you at your what question? What kind of help do you need? I'm not sure. Okay. So there was for doing demand calculations, there are work under here, under content, there's a service calculation template, service calculation here. So it's given you, this is for various calculations for service. There's a service calculation template. So this is pretty straightforward. It gives you the proper methodology that should get you to your size, to the size you need. Okay. I hope that helps. Other than that, I really don't have much more I can offer you. You guys have probably been hammered all week with lots of information. Just know that you're prepared. That's all I can say. Know that you're prepared, and that you're, when you walk in, you're going to be able to go and knock off 60% of the questions without even a hiccup. And then you're going to go back and do the calculations and then finally do the ones that you're not 100% sure on. But even the ones, even when you are, if you're hitting a question that you're not sure and you can't find the right references, you can almost infer from some of the questions what the right answer would be. So there was one question that we covered where it was, let me see, what was it? Got my notes here. It was 91 where they were asking about overcurrent protection for some form of an appliance, and the correct answer was a circuit breaker certified under blah, 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 blah. But the other three possible answers were all using terminology that once we found the rule was section 14, and the reference in the other three all use terminology that was disallowed or not allowed. So when you start looking, if I would have had to have guessed at that question, I would have guessed the right one just from the way that the questions are structured. So again, don't make the mistakes that I made. Make sure that you read the questions properly and make sure that when you're looking at the code reference or the tables that you're looking at all that information. Okay, so that's about it. Good luck with your CFQ. Keep at it, and know that you're all going to be working. You're all going to have six-figure incomes as licensed electricians. So good luck with that, and enjoy it. Work safe. Always lock out. Don't work. When I started, I used to do a lot of live work, and I don't anymore. There's no need to work live anymore. We were taught how to do it back in the old days, and I'm not so old that I would think that all things from the old days is good. I'm glad that we don't have to do any live work, or we don't have to do much live work. It's always better to lock out and test first, and then do your work in a safe manner. And so good luck with your CFQ, and just keep on going. Okay, that's it for today. Go outside and enjoy some of that nice looking weather, and maybe I'll see you on the job site. Okay, take care.